Good afternoon, everyone. My name is Steven Valencia, and I am doing the disease risk prediction research with my advisor, Dr. Siwei, and my mentor, Ji Zhang. So what I'm going to be doing, or what I did, was create something that can possibly, perhaps, be more accurate than an actual doctor. Like as you can see in this picture, on the left side you see the computer. So at the beginning we have an image, and we're trying to find out if it's cancer or not cancer. So if you look at the computer, you see all those images it can actually store. A computer can store a lot more images than what an actual human can, because obviously human limitations. You can see the computer has a whole bunch of images of cancer in the back, and the doctor, he's kind of iffy on what the image actually is, because he can't hold as many images as a computer can. So basically what I'm trying to say is, a computer can, if you give it enough memory, it can hold way more images. It can recognize way more images than what a doctor can, which is pretty crazy. And so yeah, so this computer, this algorithm can possibly be more accurate, can diagnose skin cancer more accurate than a dermatologist. So what I did was, my data sets were from the ISCA ISIC archive. There were 12,000 benign images, which is a lot. And yeah, so what I did was, between the cancerous and non-cancerous images, I actually picked only 1,000 images and cut those images apart. So technically at the end I cut 2,000 images and came out with 13,762 non-cancerous images and 77,000 cancerous images. So that was actually too many images. They came out to like 90,000 images in total, which was too much for the computer to handle. So what I did is I randomly selected 13,000 images in each category, which is cancerous and non-cancerous images, so the computer can actually handle it and actually train from it. So this is just a slide showing how I actually cut the images. So the original image was a picture of cancer, and what I do is I cut it 3 by 3. I just cut it to be the dimensions of 299 pixels by 299 pixels. And I could not resize the images because that would destroy the resolution, which we do not want. So to sum it all up, this is actually called transfer learning on CNN. So what I did is I got a CNN that was already trained and just cut the last layer and retrained it with cancerous images and non-cancerous images. And yeah, I trained it with the Inception version 3 CNN, which is something that Google has been working on. So it can classify different objects. So I just cut off that last layer and trained it to differentiate between cancerous and non-cancerous images. And after I train it, a lot of magic happens in the background, and at the end the computer will be able to differentiate between cancer and non-cancer. Thank you.